In this video, I will be talking about the problem linked list cycle. So in this problem, it is given that mm, we're given a linked list and a head pointer. So we need to determine whether this linked list contains any cycle or not. So suppose this is the linked list: one, two, three, four, five, and then something like this. So it is an unusual linked list. So we have learned that a linked list contains a head pointer, and after going to the next pointer, I mean the a linked list contains one part is one part contains value, another part contains next contains the address of the next next element. So for the last element, this next value points to null. So in this case, there may not be any null. See, if we travel from 1, we'll go to 2, then to 3, then to 4, and then to 5, and then come back again to 3, and then this cycle goes on and on. So just we have to determine that whether there is any cycle in the linked list or not. So there are two methods to solve this. So the first method, uh, which is it. So now, okay, so I will redraw the linked list. So now here I am at node 1. Okay, so right one. So now I will go to 2. So just after going to 2, we will reverse the direction to 1. I mean, it will look something like this. And 1 will point to null. So that we will always have a null. We are getting just a reverse linked list. Okay, with the head pointer pointing to null. So now we will then go to 3. So in this case, again the direction will be reversed and so on. This will be continuing. So at 5, we have a path from 5 to 3. So this will happen. So now we have reached to 3. So from 3, the path from 3 to other node is 2. So we will go to 2 and the direction will be reversed to this. And then we will go to 1 and then again the direction will be reversed. And after then, there is a null, I mean, on this node pointing to null address. So we will stop there. So what we can observe is that in whenever there will be a circle, so after reversing the directions, we will get back to 1. So now, if the linked list is something like this, and then it is pointing to null, so here it is a simple linked list which doesn't contain any cycle. So in this case, if we will apply the same thing, so our linked list will look something like this. Finally, 1 will point to null, then we will go to 2 and reverse the direction, then we will go to 3 and then again reverse the direction, and so on. And when on reaching 4, we will encounter null. I mean, its next pointer is pointing to null address. So we will stop here. So now we will compare the starting and the ending point. So here this was the weight. So here this was the starting point, and here this is the ending point. So now whenever there is a cycle, starting and ending point will be same. In this case, we started from here and ended at here as well. So end and start are same. So in this linked list, there will be a cycle present. So there will be one corner case for this approach. It's like if the linked list contains only one element, that is one. So this will point to null. So starting, we will start from here and we will encounter null. So we will stop. So what will be our start and end? So in this case, our start and end will be the same, that is this node only. But so according to our logic, this should contain a cycle, but it is not true. So this is the only corner case where we need to be careful. So this can be implemented in the following way. Here I have done the same thing. I have taken some two free variables to store the previous address, next address, and the current address like this, and implemented the same thing which I discussed. Now another method which we can think of is like sorry, draw the linked list. So now suppose we have a linked list, something like this. So now if I am so now in this suppose I will take two pointers. The first pointer name is slow and the second pointer name is fast. So the name suggests slow pointer will move slowly and the fast pointer will move fastly. So the fast pointer will take two steps at a time and the slow pointer takes only one step at a time. So if there will be a cycle, then at some point of time, fast pointer will be equal to slow pointer, and we will also ignore the first time. In the starting, slow and fast will be same, so we need to ignore the first. In the first, we should not consider that here slow is equals to fast, so I have to break the loop and break the cycle. So in the starting, we will ignore that slow is equal to fast. So now in the second step, in the second step, this will be slow pointer will point to this and fast pointer will point to this. And in the next step, fast pointer will take two steps. So it will reach here and slow pointer will reach here only. And now again, fast pointer will take two steps. So taking two steps, it will go to 3 and then to 4. So fast pointer will reach here and slow pointer will take one step. So slow pointer will reach here. So now slow pointer is equal to fast pointer. The address of both the pointers are same. Which means that uh, we have already, and the fast pointer has already traversed cycle of one cycle, one complete cycle, maybe more than that as well. So it has already traversed cycle, and the slow pointer is still on its way. So it's like we have a circular track. There is slow learner and there is a fast learner. So it it moves fast and it keeps on moving until it reaches the slow runner. So it's like the slow runner. will reach here, and the fast runner has taken one complete round and then again running just to reach the slow pointer. So if this is true, then there is a cycle. And if it is not true, then already, I mean, if it is not true, it can't be true only in the case when you have a simple linked list and which you have to think of. There will be a linked list and the last element will point to null. So in that case, fast pointer will immediately reaches the null pointer. So if the fast pointer reaches the null address, then we can say that there is no cycle in the linked list. This is the second method. This is also a good method to think of. I mean, it's, it can be used in some other questions as well. So that's it.